Okay, good day, everybody. This is Creatively Grateful YouTube channel, and today we'll be looking at episode 1, handling exceptions in Python. Now, it's often very easy for people to get um, handling Python exceptions wrongly, especially if you are writing a very large body of code and you need to know exactly where your errors are coming from. So today we are going to be looking at how to write an exception class that you can actually use in multiple places to handle exceptions in Python. So on the screen, I have already gone ahead to create a class, which I normally do in most of my Python projects, because normally an exception should have a code and a reason why that thing happened. It actually helps you to organize your exceptions so that you can actually process them the way you want to process them. So while defining in most of my exception classes, I do have two particular properties I normally define: what happened, the reason why it happened. Now, as you can see, this is the initialization class of my exception class. It has a variable called what and another variable called reason. Now, I keep track of these in my exception class, and I can access any of them. Do I want to? If I don't want to access them, I can always print them out as a string in Python class. So having taken a good look at this simple exception class handling, let us go into details about how to use them in our project. This is a usage scenario. I have created um, a simple class in Python called Creatively Grateful, and this simply does what this class simply does is to assign numbers from 0, yeah, from 2 to 13, from 1 to 13 to a variable called numbers. It doesn't do much, but the second method actually goes ahead and raises an exception. This is how an exception is raised in Python. So I am raising an exception for the class that I created. As you can see on the screen, it will always be raised creatively grateful exception. First exception will be the what, and the second string we are raising first exception will become the reason why we are raising this exception. This is just a simple scenario case, but you can actually use this pattern if you are making a database connection and something goes wrong. You should be able to highlight what happened and then the reason why it happened, and you can raise as many exceptions as you have, so long as you have a try except block that can always catch the exception that happened. Now, this is a simple description. We are going to add more to this while we continue with the tutorial. So down here, I've created an instance of the Creatively Grateful class. I assign it to a variable called ESP, and I directly call that method raise first exception, and I am trying to catch such exception, which is called Creatively Grateful exception. When that is caught, an instance of it is provided in EX, and I can print out ES. The reason why I can print out ES is because I've gone ahead to define a string method. This particular string method actually converts my object into a string. Here I'm simply formatting what happened and then the reason why it happens. So I'm going to go ahead and execute this simple script for us to see how we can use this in our class. So if I go ahead and type python ep1.py and I execute it, you will notice that what you see on the screen is actually error first exception, which describes the what, and we are raising first exception as the reason why we're having that exception. Now let's do something interesting. For example, if I come to this class that I created and I decide to add another method that will actually call the raise exception, and so that we can learn how to raise an exception that is raised from another class. So I can say define raise first exception self. So what is going to happen here is I will be calling I'll be calling the first exception method here without listening to the exception. Rather, I can choose to listen to the exception in a try catch block. For example, I can say try, and I'll say self dot raise first exception, and if I get an exception, right, I can catch it with a global exception as ES. All I have to do is to re-raise it by calling raise ES. Now let's see what happens with that to see if we are going to have success in this. So with this, I'll come here and call re-raise exception, and then we'll run execute the script to see what happens. So here we go ahead and execute the script, and then we'll see what happens. Now you notice that we still get the same exceptions as we got. Why do we have to do this? Now there are occasions where your exceptions will have or might necessarily need to go through a lot of try catch blocks, right, before it finally reaches a specific listener that actually handles the exception. Here I simply called a method that raised an exception, and instead of handling that exception in this particular method, I simply re-raise that exception so that it goes to the next try catch block that is listening, which is what we have here. Now this is where the method was called, and this is where the final exception will be handled. I can choose to handle the exception here, but there won't be any need for that, except I need to for example, format the exception before I finally raise it out here. So this is one of the good things about raising exceptions in Python, and it actually enables you to define a lot of exceptions. For example, we've defined creatively grateful as an exception. We can go ahead and define and extend this exception class. For example, I could say class creatively grateful number exception to actually extend creatively grateful exception class. Say pass, so I can raise different methods of different types of exception. Now we'll go ahead and define a method that will handle that. Raise number exception. So we are going to do a little mathematics here. So I am going to raise an exception. I would say, for example, summers. I would say range 1 to 30, 1 to 20, and I will try to sum up the entire number here, and by saying total to 0, then for x in summers, total plus equal x. Now if total is greater than 30, raise an exception. This is just a very simple example to see how we can actually raise an exception in a class, in a specific method that actually handles a logic. I would say raise creatively grateful number exception. Yeah, I would say invalid total. Then I'm going to format the number and say is an invalid total. So here I'll say simply format total. So with this, we'll go ahead and execute it and see what we'll have on the screen. Now if you notice, I am not using a try catch block here. It's because I already have a main try catch block that will actually handle the exception raised. So we'll come down and then we'll call the method raise number exception. Let's see what we'll get. So I'm going to come down here and execute exp.raise number exception, and when this is executed, we'll get something on the screen. Invalid total 36 is okay. I think I have an error in my, so 36 is an invalid number. Invalid number. So let's go ahead and try that again. So 36 is an invalid number. So the good thing about Python exception is it gives you the flexibility to build a powerful exception handling class, or maybe an application that has a very powerful exception handling feature. You can go on and extend the exception class, and everything will work as you expect it. And then you can have a single try catch block that listens on the exception, and you can always make use of the base exception class to handle the exception. For example, if I don't want to print out the entire exception as a string, but I want to format it, all I have to do is simply say print processing error, processing error, or we're trying to format what happened, dot format, so ex.get what, comma, ex.get reason. So when we do this, we'll get a formatted example of our exception error. Processing error, invalid total, 36 is an invalid number. So people, this is it about handling exception in Python. I hope to see you in our next class. So you go ahead and have a wonderful day.